Hello everyone, my name is Axel and I like to build stuff. Just this year I've designed not one but two compressed air engines, and as the name suggests, they run off of compressed air. Just listen to that performance. Now, 11 seconds may not seem that impressive, but for me at the time, it was extremely impressive. However, times have changed. You see, nowadays, it is extremely difficult to find an engine out there that is both efficient and powerful and that's easy to build. However, you do have some exceptions like Tom Stanton with his diaphragm engine, Integza in 3D printed life with their rotary engines, and Kersey and Project Things opposed piston engines. Now, all these engines are very cool and all, however, I have only one problem with them. They are all two-strokes. Now, if you don't know what a two-stroke is, I'll get into that a little later in the video, but in short, they're slightly more powerful for their lower efficiency. So, I wanted to make a slightly more efficient, but also just as powerful engine. So, after 8 freaking months of designing, printing, building, failing, and repeating, I am proud to share with you, ladies and gentlemen, the world's first ever 4-stroke compressed air engine. Enjoy. Before I start this video, I'd really like to thank the 13% of people who are actually subscribed to this channel, as you guys make these videos very possible. Just this year, you guys have been so kind enough to leave over 605 likes, 153 comments, and you guys have left over 343 subscriptions. What? That is literally insane, and I cannot thank you guys enough. You guys make these videos very possible, and if you want to see more projects like this in the future, please consider subscribing, as it seriously helps me out. Now, onto the video. In my last video, I tried my hand at designing a 2-stroke compressed air engine. As the name suggests, it's a 2-stroke engine. Now, let me explain to you the difference between a 2-stroke and 4-stroke engine really quickly. A 2-stroke engine, like any other piston engine, has a piston that moves up and down, that eventually turns a flywheel. Now, this piston, every time it reaches the top, gets powered, and then when it returns, it gets powered again. Every time it comes down, it is being powered. Now, in a 4-stroke engine, every 2 times the engine comes up and down, it's getting powered. So this is actually a very simple way of chasing efficiency, because while the 2-stroke engine, if it were running at 500 RPM, would only be getting about 500 explosions a second, this engine would only get 250. So this is part of the biggest reasons why I want to try my hand at building a 4-stroke engine, besides the fact that it has never been built before. But here's the deal, how is air let in? That's a good question. Normally, people have just used a push rod that's been directly connected to the crankshaft. So every time the piston comes up, a small push rod is opened. The only problem is that I tried promising that I would build a multi-cylinder engine out of this design, but there was only one problem with that. I wanted to chase efficiency first and try and design a more efficient engine, but also, I've already tried with my V-twin engine. The main problem with having a airlock valve system like that is the fact that there's way too much friction, it's extremely difficult to start, and it's extremely aggravating to have to reprint parts for this. On top of that, there's no way for it to be a 4-stroke because every time the piston goes up, it lets air in. So I don't know how to make that a 4-stroke in the first place. So I'm gonna have to redesign my entire engine from the ground up. And if you're wondering, hey Axel, why not just build a more powerful 2-stroke engine? That would be really cool and it would sound good. Well, it's mainly because if I can get a 4-stroke engine that runs just as well as a 2-stroke engine, why not have a 3-minute runtime instead of a 1.5-minute runtime, right? It would be more useful in RC applications too, and it would partially be more reliable due to less power strokes. But Axel, I hear you ask, there's no need for a compression cycle. Well, you're right, there's not. The reason why I'm doing a 4-stroke engine is just to chase that simple efficiency of being fired twice as often. I'm not trying to compress any air because it's being powered by compressed air, right? So here's my first design. So my first idea was to use a 2-cylinder 4-stroke engine that would have 2 cylinders in a 360-degree orientation. This would allow, every time the pistons went down, one of them would be powered, so it'd be similar to a 2-stroke, except for twice the displacement. So I'm also going to use the world's first ever timing belt system to to get the 2-to-1 camshaft ratio, I need to have the pistons fire every other time. This was a major killer in the engine, which I'll explain a little later. Then with this camshaft spinning, it would just push 2 little push rods that would open a ball valve. Seems simple enough, right? Okay, so I just finished building the engine. It's right here. It looks quite sweet as a model. But now it's time to test. Now, because it's there's never been a 4-stroke engine built on the internet, I'm technically the first one doing this, and I'm gonna see. I'm pretty sure this thing will have too much friction, knowing my horrible past with 2-cylinder engines. I'm gonna test it. This is with like the version 9 crankshaft I've wasted so many hours trying to get this thing into one piece, and I've also done some off-camera testing and it hasn't worked. So I'm really hoping it works this time. If it doesn't, then I have to go back to square one. Make sure the valves are adjusted. There you go. 3, 2, 1. I don't know. I don't think I have the materials to be able to build a functioning engine of this size right now with the belt. I can't figure this out right now. So I tested the engine off camera, and lo and behold, the belt was slipping. This would mean that the timing belt would get out of time and it would just try and open the valve whenever the pistons were out of sync. This would actually end up messing up the engine, and I could not get it to run whatsoever I did. I also found some more issues, like the doubled friction from twice as many pistons, the leaking out of the cylinder head, and a bunch of others that I really don't want to get into a lot of detail, because all you guys want to see is the engine running. So let's continue on. That was a bad idea. So my next idea was to, instead of using the camshaft up top with a timing chain or timing belt, my idea was to move the camshaft down closer to the crankcase to use gears to power it. Here's my idea. So my new design is actually going to be quite well inspired off of the CRF 250, which has a 16mm bore and a 9mm stroke. This engine, even though it may have a slightly larger displacement, shouldn't affect its efficiency very much because it's a 4-stroke. Yeah, don't listen to this nut. He was completely wrong, and it ended up just giving the engine more power, but that's for you to find on later on. If the 4-stroke version of this engine doesn't work, I can at least switch out the gears for a 1-to-1 ratio for a 2-stroke engine. Haha, very nice. So because I've been working on this engine for, no joke, 3 months, I actually didn't end up keeping any of the footage I kept because it was just way too much to put in one video. So instead, let me explain it pretty quickly in CAD. Also, if you don't want to watch this part of the video, then please go to the timestamp right here, but I'd really like it if you stayed, because you might be able to learn how to design your own engine, and also, it'll help me a lot with this video. But anyway, on to the build. Anyway, this engine is very similar to any of the engines I've built in the past, with the same press-fit crankshaft that I've used in the 2-stroke engines. If you don't know what this means, there will be a video link up there if you want to watch that, but it's pretty self-explanatory. Once you've got everything together and your bearings are inserted onto the crankshaft, press fit the assembly into your oil pan. Now before doing anything else, I would just like to say a quick fair warning that these parts are only tolerated for my printer in my settings. I would highly advise that you sand the parts instead of forcing them together, because that's what caused this engine to take 3 months to build and test. It'll save you a lot of frustration, a lot of misprinting, and overall, it'll just be a better experience if you are patient. So, there you have it. Next, the camshaft. The camshaft just requires a pair of 5x16x5 bearings. Press fit these onto the shaft and press the whole thing into your oil pan. Your engine should look like this at this point. Now, take your timing gears and press them onto the respective shafts. Make sure to align them with these little squares that line up. After you've pressed the gears onto the respective shafts, then press fit the jug assembly on top, making sure that the piston and push rod almost have no friction without lubricant. Then once your engine is at this point, take the flywheel and attach it as balanced as you can and spin it. If that piston can't do a whole rotation without stopping, keep sanding. You'll love yourself later. Then get out the Ninja Flex head gasket or some other gasket material that's 1mm thick and align it with the jug. After this, the cylinder head has a recess in here for an O-ring and the 6mm ball bearing. Then the cylinder head is bolted onto the jug with this gasket snug underneath. If you got through all of that without clicking off, thank you so much. Now, on to the test. Welcome back. If you just got back here from skipping through the build process, or if you stuck with me, again, thank you very much, we're about to test this engine. Okay, here we go. I'm excited. 20 PSI test. Here we go. Now it's on a different cycle. That is leaking way too much. So, I've done a little bit of troubleshooting. The ball valve is actually seating, just on this, it's seating on the actual O-ring. The problem is, the push rod is too long. So what I'm gonna do is I'm gonna sand it, I'm gonna finish this bag of chips that I started, and then we're gonna test again. Okay, so I think I fixed the problem. It at least is no longer leaking as bad. It still leaks, and I'm pretty sure that is from the bike pump thing. But now, it no longer bleeds through, and I'm pretty sure that's because the push rod was slightly too big, by like probably 0.6 of a millimeter. So, what I'm gonna do now is I'm gonna pressurize it up. If it holds long enough, I'm gonna spin the wheel. If it breaks, I'm gonna have to cut the video off. This has been way too long. And this is the world's first, so it's more of an experiment than anything. No! No! Way! Yo, let's go! Let's go! Ah! 3 months! And you finally worked! Yes! Okay, now it's leaking. What's funny is the fact that this engine, you actually have to start it up at the right time. You have to rotate the engine. Okay, here we go, 60 PSI. No freaking way! It does not like low pressures, that's for sure, which is a little unsettling. But dude, it freaking worked! Let's go! 40 PSI. There you go, that's 40. It does run down pretty high. You guys have no idea how long I've been waiting for this. I'm absolutely shocked, to say the least. And that was just amazing. Holy mackerel. What I'm planning on doing with this is I want to make an RC motorbike or quad, depending on like how big the engine ends up being, because this engine seems to be pretty powerful with such a large flywheel. And so if I can build a throttle system by using an electric compressor to vary output, then that'll be sick. Gonna do a few more test runs because let's face it, like, absolutely wonderful. That is 40 PSI. Here we go. I don't know what it was. Timestamp's down there, but I'm assuming it's like, what, 7.5-ish seconds? Somewhere around there. But I'm actually gonna go grab the tachometer and see how high it's really revving if it's running out of air that quickly. Because this is less leaky, actually, than the last engine. Okay, so here's what's gonna go on for the speed test. I have my digital tachometer right here. You guys remember this? The last time we ran this engine, it was something like 4,900 RPM. That was with the 2-stroke. Now for this, I'm going to measure the camshaft speed. I'm gonna measure this. So what I'm gonna do is I'm gonna pressurize this to 60 PSI, unplug it so that it bleeds down to about 50, and then I'm gonna start it. I really don't know what to expect. At this point, I'm already happy. So here we go. Okay, that is 60 PSI. Here we go. That was definitely a much lower RPM than the last test. I wonder if that's because I let it bleed too much. But that time we got 1300 RPM at the cam, which means we got just about 2600 RPM at the flywheel. I'm gonna do that test again, just with less time of a delay. Yo, that was almost 3000 RPM at the crank. That's insane. There went the cylinder head. I shouldn't have went that high. So, we actually broke the engine. Woohoo! Another 12 hours of printing. But anyway, I think that's a really good point to end off. We made a world's first. I would like to thank, the first 50 people that actually watched this video all the way through. So, thank you very much. This is a huge moment for all of us wacko engine building people on the internet. This is only the second compressed air engine ever built, and the last one ran on 200 PSI. This runs on 40. So, I think we just made history. Thank you very much for watching, and let's head to the outro. So, the engine runs. Yes! Yeah, and the result for me was also a little confusing because the engine has half as many power strokes, but yet it still revved 1000 RPM faster. What? Now, I'm pretty sure that 0.3 millimeter displacement difference might have a big impact on this engine, but I mean, that was still, insanely surprising for even me. Now, I'm pretty sure there are still a few ways that I can make this engine even more efficient because it only ran for, 7 seconds? I think a few ways of doing this are improving the tolerances between the push rod and the ball valve, moving the whole assembly closer so then you decrease the volume of the cylinder head, and also just getting better seals because those seals were pretty bad in the first place. So, I'm pretty sure if I were to add an exhaust valve that could vent the engine and let that piston just run up and down, this would actually increase efficiencies because it's getting rid of resistance. Now, you guys are probably way smarter than me, so leave any ideas you have to improve this engine's efficiency down in the comments below. Yeah, but really, please give me your guys' ideas down in the comments below. I read almost every one of your guys' comments. You guys are so cool in the comment section. You guys have helped me so much throughout my 1.5 years of being on this platform. Do you guys want to see an inline 2 engine? Do you guys want to see an inline 4 engine? Should I base an inline 4 engine off of the F22C? You know, the S2000 engine? Or are you guys looking forward to a compressed air powered quad? Please let me know your ideas in the comments, and also any ideas that you may have for a future video. The most liked comment that you guys leave will be selected for a future video project. Also, I'd like to really get in touch more with you guys on this platform, but the only way I can really do that, besides making cringy shorts, is by using the community tab. Now, I do not have access to the community tab right now because I don't have 1,000 subscribers. So, as kind of like a New Year's resolution, I would really like to try reaching 1,000 subscribers before the end of next year. So, if you want to join this channel and really help me out with these projects, or even be featured in them, please consider subscribing and leaving your ideas down below. So yeah, if you want to see more of my content or be more involved in my projects, please consider subscribing. Also, I have made all of the files for these engines down in the description below for free for you to download and be able to build at home. Also, I would really like to thank you guys one more time for being such an amazing community and being able to support me through this year. With all that, I would like to seriously thank you guys very much for watching. This is sadly all I have time for this month, but I am very glad I was able to finish this project and that I was able to share it with you guys. And again, please tell me what you think. So with that, thank you very much for watching. Please consider subscribing, and I'll see you in the next one. Goodbye.